right, so page 2 of your review packet, which is finding the zeros of the polynomial equation. We went over this today in class, and we're going to go over it as well together right now. So to start with, let's take a look at how we find the zeros of a polynomial function. So we initially find the zeros first by graphing this on our graphing calculator. So if you were to put this function right here into your graphing calculator, you would get that this crossed the x-axis at -4 and 5. So if you have your graphing calculator right now, go ahead and practice putting in this equation. If you need to pause it for a second, go ahead and pause it, put the equation in your calculator, and then see that it crosses the x-axis at -4 and 5. Now once you have done that, you have to then perform synthetic division. Okay, synthetic division is where you take basically the coefficients of the polynomial, the original polynomial, so 1, -1, -16, -4, and -80, and you divide them by the two solutions. So you can first divide by -4. When you do all that synthetic division, you get the result of 1, -5, 4, -20, and 0. Then what you're going to want to do is you're going to want to divide by the second solution, which is 5. So you then perform the synthetic division one more time, and you find that you get 1, 0, 4, and then 0. This is now your quadratic that you can find the imaginary solutions with. So a equals 1, b equals 0, and c equals 4. You then plug those into the quadratic formula, -b plus or minus the square root 0 squared minus 4 times a times c all over 2a. Now the 0, -0 goes away because it's nothing. 0 squared is nothing, so you're really just left with -4 times 1 times 4, which is -16. Your plus or minus sign doesn't go anywhere either. So you bring down the plus or minus and you take the square root of -16 over 2, which gives you plus or minus 4i over 2. 4 divided by 2 is 2, so you have plus or minus 2i. So now you have 4 solutions. You have -4, 5, was your original 2, then quadratic formula gives you 2i and -2i. Again, at any point if you need to pause the video, you can. Alright, so for number 4, you do the exact same process. So you're going to want to first graph this polynomial. You see that it hits the x-axis at -3, but since that is actually where it curves back up, the vertex is sitting on the x-axis, so therefore it's called a double root. So this actually hits it twice at -3 and -3. So you actually have to perform the synthetic division twice in order to get your quadratic. Then you get your quadratic, a equals 1, b equals 0, c equals 25. Plug it into the quadratic formula. Once you do that and simplify, you get plus or minus 5i. So now you have 4 solutions, but really -3 is the same number, so you really don't have to write it twice. You really just have to write -3, 5i, and -5i. Okay, the last one on this page, as for actually number 5, again, you do the same exact thing. Okay, this one though is a cubic, so it only has 3 solutions. It only has one real, so it crosses the x-axis at 3. You perform the synthetic division once, and this is the quadratic that you're left with. So when you plug it in, it doesn't simplify quite as nice because b is not 0, but you can just leave it as 4 plus or minus 2i over 2. So your 3 solutions are really 3, 4 plus or minus 2i over 2, and 4 minus -2i over 2, or 4 minus 2i over 2. Okay, so again, if you need to pause this, go ahead and pause it. If you need to rewind it because you missed something that I said. But it's the same process 3 different times for number 3, 4, and 5. All right, moving on to writing polynomial functions with the given zeros and a leading coefficient of 1. Again, this is really just writing the function as a set of binomials. So the zeros of 1, -3, and 4 become x minus 1, x plus 3, and x minus 4. The solutions of 5, -5 with a multiplicity of 2 become x minus 5, x plus 5, and x plus 5. The solution of 3 with a multiplicity of 3 is just that 3 times, x minus 3, x minus 3, and x minus 3. And then for your zeros of 0, 2, -2, and 6, it's really x plus 0. You don't need to write x plus 0. You really just need to write x. X minus 2, x plus 2, and x minus 6. All right, moving on. All right, let's go back to number 2 because I realized we started with page 3. That's fine. In number 2, actually, you know what? I'm going to save number 2 for another video. So you can just go ahead and stop this video now.